Hello everyone, let us take the problem number 4, that is y of t is equals to 0 for t less than 0 and it is equals to x of t plus x of t minus 2 for t greater than or equals to 0, and we have to check whether this continuous time system holds the property of memoryless, causal, linear, stable and shift invariance or time invariance property. Let us solve it. So I will tell you the definition of memoryless system. The system is said to be a memoryless if its output depends upon the present input value only. Then we are calling that system as memoryless system. So let us consider that is output at t is equals to t1. That is your y of t1. Y of t1 is equals to 0 for t1 less than 0 and it is equals to x of t1 plus x of t1 minus 2 for t1 greater than or equals to 0. Okay, you can see that this is your x of t1. Y of t1 is equals to x of t1. That means this x of t1 is your present input. Okay, present input values, and this is x of t1 minus 2. X of t1 minus 2 is also your past input value. This is your present and this is your past input values. So by definition of memoryless system, whether the system is memoryless or not, no, the system has memory because its output depends upon the past input values also. So we can say that the system is dynamic or it has a memory. It has a memory or the system is dynamic. What about the second? That is causality. The system is said to be a causal if its output depends upon the present and past input values only. So you can see that here it depends upon the present and past input values. So we can say that the system is causal. I will write it here for this particular system. The system is causal and it has memory. It has memory. Now let us go for the third property. The third property is your shift invariance property. So in order to check whether the system is time variant or not, okay. So what is the definition of time variant system? The input, the shift at the input results in should be shift at the output. Then we are saying that the system is time invariant system. If this is not true, that is shift in the input doesn't correspond to the shift at the output, then we are calling that system is time variant system. Now let us consider the first we will consider the shift at the output. So shift at output by t0 y of t minus t0 which is equals to 0, which is equals to 0 for now whenever t is there. Okay, whenever t is there, because our output is shifted, so whenever t is there you have to replace it by t minus t0. Okay, so t minus t0 less than 0. Okay, less than 0, and it is equals to x of t minus t0 plus x of t minus t0 minus 2 for the limit t minus t0 greater than or equals to 0. Fine. So t minus t0 less than 0, you can rewrite it as t less than t0. Okay, because this minus goes to this side. So t less than t0, you can rewrite it as t less than t0. What about this? T minus t0 greater than 0. That means you can rewrite it as t greater than or equals to t0. Remember this. Okay. So first step is completed, that is shift the output by t0. Now let us shift the input. Let us shift the input by t0. If we shift the input by t0, we are representing it as x of t minus t0, okay? Or we can represent it in terms of y also, y of t minus, sorry, y of t comma t0, y of t comma t0, okay, which is nothing but we are just, I'm just writing that is x of t minus t0. We are just shifting the input only, just shifting the input only, which is equals to, so this becomes 0 for t less than 0, okay, t less than 0, this becomes 0. What about this? This becomes x of t minus t0 plus x of t minus t0 minus 2, okay, this I'm writing at this side, okay, so for t less than 0, and this is t greater than or equals to 0, and this is your y of t comma t0, or you can say input is shifted by t0. So what is this value? This is 0 for t less than 0, and this value is this value x of t minus t0 plus x of t minus t0 minus 2, which is for t greater than or equals to 0. From these equations, from these two equations, this is equation 1 and this is equation 2, okay. From this equation, it is clear that the shift of T0 at the input doesn't have a corresponding shift in the output, which implies that, what it implies? This implies that the system is time variant. The system is time variant. The system is time variant. Now what is left? Left is linearity property. So in order to check linearity property, we have to make two outputs, that is y1 and y2. And when we call the system is to be linear, if it follows the superposition theorem, then we are calling that system as a linear system. So let us consider y1 of t, which is equals to 0, okay, and for t less than 0, okay, this is t less than 0, and it is equals to x of t plus x of t minus 2 for t greater than or equals to 0, this is y1 of t, okay, and then y2 of t is equals to 0 for t less than 0, and it is equals to x of t plus x of t minus 2 t greater than or equals to 0. Now x3 of t is nothing but the linear combination of x1 of t plus x2 of t. x3 of t is nothing but the linear combination of a1 x1 plus a2 x2. This is not the linear combination. So what is y3 of t? Y3 of t is equals to 0, 0 for t less than 0, and it is equals to a1 x1 of t, okay, a1 x1 of t plus a1 x1 of t plus a2 x2 of t, okay, this is for this x1 of t, okay, now plus a1, okay, x3 of t, a1 x1 x1 of t minus 2 plus a2 x2 of t minus 2. Fine. So that is equals to 0 for t less than 0. Okay, and this term is for t greater than or equals to 0. So comes to this y3 of t is equals to 0. Now from this term a1 x1 and this we will take as common. So a1 we will take common and this will becomes a1 x1 of t. Okay, so plus sorry. So a1 I have taken common x1 of t plus x1 of t minus 2 plus a2 common from these two terms x2 of t plus x2 of t minus 2. But what is this total? This becomes see a1 x1. Okay, so x1 of plus x2, x1 of t plus x1 of t minus 2, x1 of t plus x1 of t minus 2. So this is y1. I will rewrite it here. y3 of t is equals to a1 y1 of t plus a2 y2 of t. y3 of t is nothing but a1 y1 of t plus a2 y2 of t. So it is clear that this system follows the superposition principle. Therefore, we can say that this system is linear system. So I will write it here. The system is linear system. Now what is left? Left is your stability property. We have to check whether the system is stable or not. In order to check the system is stable or not, we have to give stable input to the system, and if the system produces stable output, or you can say bounded output, we are calling this system as a stable system. If we give stable input, or you can say bounded input, which should produce a bounded output. So let us consider x of t is less than infinity, or you can say magnitude of x of t is bounded for all the t. For all, what is magnitude of y of t? Magnitude of y of t, which is equals to, okay, here we have given which is equals to, it is equals to 0 for t less than 0, and it is equals to magnitude of x of t. So it is equals to magnitude of x of t plus, not plus, okay, magnitude of x of t plus x of t minus 2 magnitude. Okay, and this is for t greater than or equals to 0. But we know that mod of a equals b is less than or equals to mod a plus mod b. So what is y of t? Mod of y of t is equals to 0, okay, for t less than 0, and it is equals to mod of x of t plus mod of x of t minus 2. So this is nothing but the input. This is a shifted version of input. Okay. So we can say that if our x of t is bounded, your x of t is also bounded. This shifted version of input signal is also bounded. Okay. This implies that your mod of y of t is also less than infinity. So we can say that the system is stable system. Right. So the system is stable system. So this particular system y of t is equals to 0 or t less than 0, x of t, it is equals to x of t plus x of t minus 2 is causal. It follows that it is causal system, it is linear system, and it is stable system. This three property this particular system holds, and this two property, that is memberless and invariance property, this system does not hold. Okay, so you got this. Now let us take another example, that is your example number 5. Example number 5. Example number 5. So example number 5 is y of t is equals to 0 for t for x of t less than 0, x of t less than 0, and it is equals to x of t plus, then x of t minus 2 is there. Okay, and for x of t greater than or equals to 0. Okay, so let us check which property this particular continuous time system holds. So at t is equals to t1, we'll find out the output at t is equals to t1, so which is equals to y of t1, which is equals to 0, for x of t1 less than 0, and it is equals to x of t1 plus x of t1 minus 2 for x of t1 greater than or equals to 0. So you can see that this is your x of t, this is x of t minus 1. Okay, so output y of t1 at t is equals to t1 depends upon the past values, that is t minus 2, and the present values, that is x of t1. Therefore, according to the definition of causality and memberless system, this particular system is causal system. This particular system is causal system, and this particular system has memory. This particular system has memory. So I will write it here. This system is causal system. Okay, and this system has memory. The system has memory. Apart from that, in the earlier example, we have seen the same example. Okay, so if you try to solve by looking at the earlier examples, you will find that this system is also linear, the system is also time invariant, and the system is stable. The system is stable. So you can try in this example. If you are not getting that, you can ask me. Okay, now we will stop for this particular example. We will see sixth example after this class.